Good morning. So this is a numerical problem in which you have a box. Okay, this is a box. The box has a weight capital M. Okay, and there is a person, inside the box, and this could be a lift. So we can say this is a lift, and this is a man. Okay, so they have some mass, in kilograms. Now, it is given in the situation that the man is holding this massless, rope. So that's your, rope, and this is massless. The pulley is also massless. The question is, there is a weighing scale here, okay? So you have a weighing scale here. What is the reading of the weighing scale? How do you calculate that? Just for your knowledge, and so I will just discuss this and tell you what exactly is going on in this problem, so that you can. So that's the maybe the lift, and the person is in equilibrium. The person is not going up or going down. So the question is, what is the measurement of the weighing scale here? So you have a weighing scale. All right, so let's discuss many so the way to do this numerical is essentially to rely on basic concepts, okay, and the free body diagram. So let's say you try and make the free body diagram of, the box, okay. Now the box, if you see, is, connected to the string here, okay. So this is where the box is connected to the string, and therefore, the box is being pulled upwards by a tension T. And the earth will pull the mass downward with mg. Also note that the man and the block, okay, the man and the block, they are touching each other. So there is a contact force concept, right, which is action and reaction, okay. So when you have two surfaces on top of each other, there is a internal action and reaction which needs to be considered. So assume that the boy is receiving some normal reaction, and this is a normal reaction which is coming from the surface of the block or the lift to the man. So the man will also exert a normal reaction on the block. So you can see, this N is on the boy or the man, and this N, is the reaction which the boy gives back to the block. So you can see force number 1, 2, and 3, are acting on the lift or the block, whatever you want to call it. So therefore, you can write that tension is equal to N plus mg, because this is where the equilibrium is being attained. All right. Now let's look at the boy itself. Now, if you look at the boy, the boy has a mass, and therefore it is being pulled by earth with a force of mg, okay, where m is the mass of the small m, okay. And then, this man is in touch with the string here, so this man experiences an upward force here. And obviously there is a normal reaction which is, coming from the lift, okay, where the man is standing. So you can write the man is also in the state of, so you can write T is, the tension, which is in the upward direction, and the normal reaction is equal to mg, okay. So this is the equation for the man, where the tension plus normal reaction, gives you the idea of, let me just adjust this a bit so that you can see it more clearly. and understand the problem statement, okay? Now, this is tension plus, normal reaction is equal to mg. So you have two equations, and the tension, throughout the string is same. So the same string carries the same tension, and that is why I have taken this tension, acting on the boy or the man to be T, and the tension on the block or the lift also to be T, because the tension has to remain same throughout a massless string. That's a basic concept. All right, so you have two equations, which is T is equal to N plus capital Mg, and so you can find the value of tension and substitute in the equation number 2. It will come out to be N plus capital Mg plus N is equal to Mg, and 2N is equal to Mg minus Mg, and therefore the normal reaction is Mg minus Mg upon 2. Okay, that's your calculation of the two equations which you have done. These two equations have been considered for the purpose of solving. Okay. Now, if this is so we applied many concepts in this question. Okay, we applied that the tension is constant. We also applied the fact that normal reaction is acting in pairs, and we used free body diagram as the base to calculate this numerical. You can see the normal reaction is this. Now, the importance of normal reaction has to be understood. See, normal reaction essentially, like I'm sitting on the chair and earth is pulling me down. A lot of people believe that the force of gravity is the one which is responsible for making us feel our weight. That is not correct. What is actually making us feel our weight is the normal reaction. Okay, that normal reaction that passes through us is the main cause of making us feel that we are heavy. Okay, like we feel heavy. A lot of people believe that our weight is the gravitational attraction. It is not. It is the normal reaction that passes through us that makes us feel our weight. And therefore, this normal reaction, which we calculated, with the help of, if you see this is a normal reaction which you calculated, is the reading on the weighing scale. So if you have this, situation where you have normal reaction, the weighing scale will give you the reading which is actually the normal reaction. Okay, so the normal reaction is the reading in the scale. I hope this gives you a glimpse of what is normal reaction and how do you handle such a question with multiple. I think the main problem here is the fact that you have normal reaction between the two, which gets very difficult. And if you draw the free body diagram very carefully, you can actually solve the both the equations and make the equations. Thank you very much.